Chapter 2.6 is going to be ratios, proportions, and percents. So starting with ratios first, a ratio is just a comparison between two quantities using a quotient. So it's just a number divided by another number. There's going to be three different ways we can write ratios. So I'm sure we're all used to the last way how to write a ratio because it's just division, A over B. Another way to write it is using a colon. So that's A to B. And then the other way is literally what I just said, A to B. So these all mean the same exact thing. So let's do a little example here. So let's write a ratio for each word phrase and express the fractions in lowest terms if we can. So for the first one, we have 5 hours to 3 hours. So they do have to be the same units. So these are the same units, they're both hours. So as a ratio here, we have a couple options. So I'm going to use the fraction one. So 5 to 3, that's going to be 5 over 3. So pretty simple. The hours cancel. We have 5 hours over 3 hours. Hours over hours, they cancel, and we're done. So that has to happen most of the time for these ratios. And for the next one, we have 6 hours to 3 days. So this time we need to get either hours into days units or days into hours. It's going to be a little bit cleaner if we rewrite 3 days into hours. So there are 24 hours in one day. So that means we're just going to multiply 24 hours times 3. So in 3 days, that is equivalent to 72 hours. So now we're comparing 6 hours to 72 hours, which is going to be 6 over 72. Hours over hours cancel each other. In lowest terms here, they both have a common factor of 6. So we get 1 over 12, or 1 to 12. Okay, so that's ratios. Pretty simple, probably. So next, for proportions, getting a little bit more complicated. So proportions, we know that a ratio is used to compare two numbers. A proportion is going to say that two ratios are equal. So we're going to have one ratio equals another ratio. That is a proportion. So for example, let's say we had 15 over 20. That's a ratio, right? We know that this is equal to 3 over 4 because we can simplify it. So now this is a proportion. We have a ratio equals another ratio. So now it's a proportion. So in general here, a proportion is just going to look like what I have right down here. We have A over B equals C over D. And A, B, and C, and D are just going to be called the terms of the proportion. So something that's pretty useful when we're dealing with proportions is what we call cross multiplying. So technically, this is nothing new. It's just another way of thinking about it and some other terminology. So when we're dealing with a proportion A over B equals C over D, what we can do is we can multiply both sides by the least common denominator, which in this case would be B times D, just multiplying those denominators together. So what we would end up with is we would end up with AD equals BC. So starting with the proportion A over B equals C over D, we get AD equals BC. Okay, so when we think of this as cross-multiplying, so trying to make this a little bit more sense now, what we can do here with this proportion A over B equals C over D, we're going to multiply this denominator up here, and then we're going to multiply this denominator up here. So you can see why it's called cross-multiplying now. Technically, we're just multiplying both sides by B and both sides by D. But what we end up getting is A times D equals b times c. Sorry, I shouldn't have put an equal sign there. Just put a little arrow. Okay, so that's all cross multiplying is. It's pretty simple. So let's do some examples so we don't have to work with generic letters so you can actually see numbers in action. So let's decide whether each proportion is true or false by cross multiplying. So if we want to know if 3/4 is equal to 15 over 20, obviously we can just reduce the right side of the equation, reduce that fraction and make it equal. But let's do it with cross multiplying. So cross multiplying means we're going to take that denominator, multiply it up there, this denominator, multiply it up there. So this is going to be 3 times 20 equals 4 times 15. And we're checking to see if these are equal. So this is going to give us 60 equals 60. So that means that's obviously correct. 60 does equal 60. So this proportion is true. So for the next one, for B, we have 6 over 7 equals 30 over 32. So maybe at first glance you can't necessarily tell if that's going to be true or not. So let's cross multiply. So that denominator over there, this one up here. So it's going to be 6 times 32. And we want to see if that's equal to 7 over 30. So 6 times 32. 6 times 32 is going to be 192. And 7 times 30 is going to be 210. So that's obviously not true. 192 does not equal 210. So this original proportion is false. Okay, so this cross multiplying is going to come in handy when we're trying to solve equations. So let's say we have the equation 5 over 9 equals x over 63. So technically what we could do here, and which would be a little bit shorter actually, is if we multiplied both sides by 63. But let's think about this as cross multiplying. So cross multiplying, it's going to be 5 times 63 equals 9 times x. So denominators to other numerators. Okay, so 5 times 63 is going to give us 315. And then we have to divide both sides by 9. So when we divide both sides by 9, we get x equals 315 over 9, which ends up giving us 35. So that means 5 over 9 equals 35 over 63. Keep in mind that cross multiplying is only a thing when we're dealing with an equal sign. We're talking about crossing through the equal sign, not when we're multiplying fractions. Okay, make it a little bit harder here. So we have m minus 2 over 5 equals m plus 1 over 3. So we're going to multiply denominators to the opposite side numerators. So we're going to get 3 times m minus 2 equals 5 times m plus 1. So now we're going to solve this for m. So we have to distribute on both sides. So we get 3m minus 6 equals 5m plus 5. Let's get all of the m's on one side. So I would usually get the m's on the right hand side because it would be positive, but just to do it a little bit differently and make it a little bit harder, I'll get the m's on the left, which means they'll be negative. So it's going to be negative 2m minus 6 equals 5. Going to add 6 to both sides. Cancels on the left. We get negative 2m equals 11. Divide both sides by negative 2. So we're going to get m equals 11 over negative 2, or just negative 11 over 2. So it's a little bit messy, but that is okay. Okay, so now let's actually do some proportion examples that are actually word problems and something that actually kind of comes up in everyday life here. So after Leanne pumped 5 gallons of gasoline, the display showing the price read $18.10. When she finished pumping the gas, the price read $52.49. We want to know how many gallons did she pump. Okay, so 5 gallons cost $18.10. And then X gallons cost $52.49. So what I'm going to do is price per gallon equals price per gallon. So I'm going to say $8.10 over 5 equals $52.49 over X, because that's what we're looking for. How many gallons did she pump? So really important, we have price in the numerator, and then we have gallons in the denominator. They have to be that way on both sides of the equation. So they're both price per gallons. So let's solve this by cross multiplying. So it's going to be this one to that side, this one to that numerator. We're going to get 18.1 x equals 5 times 52.49. And obviously I just dropped the dollar sign here, which is fine. Okay, so for the 5 times 52.49, the right-hand side, we end up with 262.4.45. And now to get x by itself, we need to divide both sides by 18.1. Okay, so that gives us x alone on the left. So 262.45 divided by 18.1 gives us 14.5. So this is in gallons. So let's see if it makes sense. So we said our answer is 14.5 gallons. So 5 gallons was $18.10. 14.5 gallons cost $52.49. So sure, makes sense. We didn't get some crazy number. It seems reasonable. Okay, so we can also use proportions to convert units. So for example, if we wanted to convert feet to meters or pounds to kilograms, we could set up a proportion and help us solve it. So let's do these examples. So there are approximately 1.6 kilometers and 1 mile. We want to know the distance in miles of 20 kilometers. So setting up a proportion here, we're going to say that there is 1.6 kilometers for every 1 mile, which is going to equal, we are given 20 kilometers, and we're trying to find how many miles, so I'm going to say X number of miles. So this is our proportion, so we have a ratio equals another ratio. We have to make sure both sides have the same units, kilometer per mile, and then we can cross multiply here and solve this for X. So solving this for X, what I'm going to do is cross multiply. So I'm going to multiply those two and those two and say it's going to be 1.6 times X equals 20 times 1. So this is going to be, it's in parentheses, this is going to be 1.6 x equals 20. Divide both sides by 1.6, and that's going to give us x equals 12.5 miles. So there are 12.5 miles is the same thing as 20 kilometers. Okay, for the next one. Donna visited Cancun, Mexico. She stopped by a local bank and was told that $1 US could be exchanged for 18.58 pesos. We want to know how many pesos would she get if she exchanged $200 US. So setting up this proportion, we're going to say that $1 is the same thing as 18.58 peso. And that is going to equal $200. And we're trying to find how many pesos is the same as 200 US dollars. So this is going to be X peso in the denominator. So both sides of this equal sign are US dollar per peso. So we're going to cross multiply. So we're going to multiply these two, and then we're going to multiply these two. And we're going to get 1 times X equals 200 times 18.58. So I drop the units when I'm doing these intermediate steps. So 1x is just x. Do it over here. 1x is just x. 200 times 18.58, that's going to give us 3,716 pesos. So that means 200 US dollars equals 3,716 pesos. Okay, so moving on to percents. So a percent is just going to be a ratio where the second number is always 100, because that's what percent literally means. Per means for every, and cent means 100, so it's for every 100. So for example, 50%, this technically means 50 for every 100, and for 27%, that is 27 for every 100. So when we're solving problems involving percents, we can set up a proportion. It's going to be the part per whole equals X percent divided by 100%. So the percent part divided by the whole percent, which is always 100%. So solving this problem here, what is 15% of 600? So setting up a proportion, it's going to be 600 is the whole. We're looking for the part. So it's going to be X over 600. And then it's 15% over 100%. So we're saying that we have to cross multiply to find the X here. So cross multiply, it's going to be X times 100. I'm going to write this as 100X equals 15 times 600. So once again, leaving out the units, I'm leaving out the percent. So this is going to be 100X. 100X is going to equal 9,000. We divide both sides by 100. So it cancels over here, and we're going to get X equals 90. So that means that 90 is 15% of 600. So you should think to yourself, does that answer make sense? And sure, that answer does seem to make sense. We didn't get some crazy number. Okay, do a couple more here. 32% of what number is 64? So this time the 64 is the part, and we're looking for the whole. So we're saying 32% of what whole is 64. So that's going to equal 32% over 100%. So once again, we cross multiply, and we get 64 times 100 equals 32x. So 64 times 100 is 6,400 equals 32x. we divide both sides by 32. So we're going to get x equals 200. So we go back and ask ourselves, does this make sense? So that's saying 32% of 200 equals 64. So that does seem to make sense. Okay, let's do one more here. We have 90 is what percent of 360. So this time we're looking for the percent. So we have a part of 90. We have a whole of 360. We're trying to find x, which is going to be x percent over 100%. So once again, we cross multiply, and we get 90 times 100 equals 360 times x. So that gives us 9,000 equals 360x. Divide both sides by 360. And that's going to give us x equals 25%. Okay, so once again, we go back and check to make sure our answer made sense. That's saying that 90 is 25% of 360, which is true. Okay, so that is it for this section.